Okay. I don't know, can you see this? Alright. Alright, okay. This is the graph of the derivative, but the questions are about the original function. Okay? Alright, number one, on which intervals is f increasing? So this is the derivative. So we're looking for where the derivative is positive. We're looking for this value, where the derivative is positive. So here, it's positive from 0 to 1, right? These are half units, so 0 to 1. And it's also positive from, it's positive from 1 to 2. So I guess we should just say 0 to 2. Okay, the fact that it hits 0 here is of no consequence. All right. On which intervals is f decreasing? So we're looking for where the derivative is negative, and here it is. And that's going to be 2 to 4. Where does f have critical points? Well, the critical points are where the derivative is equal to 0, and it happens at 1 and 2. Well, I guess at x equals 4. Right? It crosses the x-axis here. Where does f have a local maximum? Okay, at x equals 1, nothing is happening. What I mean by that is the derivative does not change sign, so it's not going to be either a max or a min. While at x equals 2, it goes from positive to negative. So I'm addressing it 4 and 5 at the same time. Positive, negative is going increasing, then decreasing. So that's going to be a maximum. So my maximum is occurring at x equals 2. Now, or at x equals 4, it's going from negative to positive, but it's kind of the end point. One could argue because it's decreasing, then increasing, it's going to be a min. Let's just say for kicks that's the min. All right, number 6. So you're asking, well, on the quiz, which one's correct? I will accept x equals 4 as a min, because technically that's what's going on, right? Because it's going to hit a low point there. All right. On which intervals is f concave up? A function is concave up when the derivative is increasing. When the derivative is increasing. So the derivative is increasing from here to here. I don't know what that approximation is. It's going to be from 1 to like 1.7. At this point, I will accept any kind of approximation that's close to that. Here, that's 3. The derivative is increasing from here to here, so that's going to be like 3.3 to 4. On which intervals is f concave down? So now we're looking where the derivative is decreasing, and that's going to be from 0 to 1. And from here, which we agreed last time was 1.7, down to this value, which is 3.3. Let's try to be consistent with our approximations. All right, where does f have a point of inflection? All right, so a point of inflection is when the derivative hits a max or a min, right? Where the derivative hits a max or a min. And the derivative's hitting a max or a min here, right? Because it's switching from decreasing to increasing. So it's going from concave down to concave up, so that'll be a point of inflection. So we have point of inflection x equals 1, and 1.7, and 3.3. Where does f achieve its maximum value? Oh, on the interval 0 to 1. Okay. Oh, I was like, I don't know. But if we're given an interval, it's not too bad. All right. So the interval we're looking at from 0 to 1. Okay. Now this is positive the whole time. When I'm talking about the derivative is positive the whole time. So that means the original function is increasing on the interval from 0 to 1. So even though the derivative looks like it's decreasing, the original function, because the derivative is positive, the original function is increasing. So the maximum value is when it hits at x equals 1. Where does f achieve its minimum value on the interval 0 to 1? So it'll be on the left-hand side because, well, it's increasing after that. So x equals 0 has to be the lowest one of the original function. I know it doesn't look like that for the derivative. Where does f achieve its maximum value on interval 1 to 2? 1 to 2. Okay, it's still positive. The derivative is still positive, so it's still increasing the whole time. So it's at the right endpoint again. And by the same logic, it's on the left endpoint for the minimum. Assuming f of 0 equals 0, sketch a graph of f on the same axis. Now, keep in mind, there's more than one answer when we graph or sketch a graph, okay? So you want the basic shape. So if your shape looks similar to mine, but maybe doesn't go as high or doesn't go as low, that's not a big deal. And also, I'm not going to be picky about how high, how low you think this slope is, okay? All right, so assuming f of 0 equals 0, that means here, sketch a graph. It's increasing the whole time. So it looks like it's increasing sharply, right? And I hope I don't screw this up. In fact, chances are good I'm going to screw it up, so just be careful. All right, so I'm increasing. I should probably be steeper than this, but I don't think I'm going to be able to fit it on the graph if I go too steep. All right, and I'm not. Ooh. Right. Keep in mind, if the derivative is decreased, it's concave down, so it should be cool. Okay, and I level off there. But it's just a point of inflection. I'm going up, and I level off again. No, I don't level off there. What I do is change inflection. So change inflection. So I'm going from concave up to concave down, and I level off here. Right? I level off here, and then now I'm decreasing. So I'm going down. Going down. And what I want to do is hit a point of inflection around here. So around there, I want a point of inflection. So I'm concave down. And concave down. About here, I want to be concave up. And I want to hit a plateau or a level when I hit this point, x equals 4. So I know that's not pretty. I want the concavity to change around here. I guess I missed it, sorry. And I want the concavity to change around here, and I want the concavity to change around there. Okay, so it's concave down because its derivative is decreasing. Then I switch to concave up, and then I switch to concave down, and it leveled off here. I got that one right at least. And then it's concave down until it hits this point. Then it's concave up, and it should level off around x equals 4. Okay, that's a long enough video.